let's select and destruct shapes. Hello everyone, Hadil here with a new tutorial for you. Today we'll discuss one of the most fun sketches to play with that I created for 36 Days of Type. If you've seen the letter E, you'd know what I'm talking about. In the sketch, I create a bunch of selections and move the path with a bit of noise if the points are inside the active selection. For this, we'll need to create two classes, one for each point and another for a path of points. We'll be reusing the same classes for other sketches in upcoming tutorials. Let's start by creating the point class, and that will be extending the p-vector class. That means we'll be able to use its x and y properties, and I'll want to pass that to the point class so I can set the position using the point from the SVG. Now you can choose whether you want to display the points or not. I like to create a display method either way. So each point will be a circle with a variable stroke weight, as we'll be animating that later, and let's give them a diameter of 10. And also initialize a stroke color, and I'll create it up here. For now, I'll keep it at white because we'll later vary that based on the color of the shape itself, or the SVG that we're going to create, and no fill. Now for the update method, we will have a simple noise animation with cosine and sine that will require an angle that will be noise of x and y, each divided by a scale and multiplied by, let's say, 1,000. I'll create the scale to be 100 for now. And because cosine and sine produce values from -1 to 1, we'll have to multiply it by a step. I'll create an x step and y step and give them random values. Let's say from -0.5 a point or 0.5 pixel to 0.5 pixel. And the same for y. This is also considered the speed of how each point is going to move. Next, and most importantly, the selection method. I'll call it selected as it will return a Boolean. And since it's a rectangle, it'll take 4 parameters, x, y, width, and height. In this method, we'll check whether the point's position is inside the bounds of the selection, similar to checking the bounds of the canvas. This will be checking if x is greater than the selection's x, same for y, and the opposite for width and height. Because if the position of a point is greater than the selection's x and y, that means it's on the right and down from that point. And then if it's less than the width and height, that means it's above the bottom right corner and to the left of that. I'll return true if that happens. Otherwise, or in every other scenario, it'll be false. We'll stick with this for now, but later we'll have to add more scenarios. We're done with this point class, but it'll be part of the path class, which we'll be creating next. We're going up the hierarchy in creating the components of a shape. For the path class, we'll need an array of points, and we'll also pass it into the constructor. Let's pass it into the constructor, and this is going to equal to the parameter. The display for this is the important one, as it'll connect the points and create our shape. You can either go with curves or normal vertices. I created both, so I can switch if I want. That will go into a for loop iterating over the points array. Since we're using vertices, we'll have to use begin shape and end shape outside the for loop, so we have one connected shape. And the vertex method should go inside the loop and takes the points x and y as a position. If you choose to draw curved vertices instead, keep in mind that you're going to need one method call before and one after the for loop inside of the begin shape and end shape block. Because with curved vertices, you're going to need control points, and the for loop is going to take care of the majority of the control points, but for the first one and the last one in the array or in the points array, you're going to need a control point before that, and then for the last one, a control point after that. And because the shape is going to rotate around whatever we want to import into processing, it's going to go back to the original point. So it's going to start from 0, and then it will go all around and then go back to 0. So curved vertex that is going to go over here is going to be before the 0 point, and that is going to be the last point in the array if you look at it as a circle. And the one over here after the for loop, which is after the last point in the array, is going to be the 0 point of that array to continue the circle. I'm going to stick with the vertex for this, but those are the tips if you need to use curved vertices instead. I'll give it a stroke for now of white, let's say. And the stroke weight for this path, I made 60 and then no fill, because I don't want it to fill the shape. And if you choose to display the points, then you can do so after all of this. And we'll use a for in loop. So for point P and points, I'll call the display. To call the points update method and checking the selection, we'll create an update method inside the path class. It'll take the same parameters as the selected method, so we can pass that into the selected method. So we can just go and copy that. We can use a for loop to extract each point, then check if they are selected using the method, and finally, if so, updating the points. So I'll grab each point in here. You don't have to do this, but I'd rather use one letter or one character than this whole thing. And then if this point is selected, and I'm going to pass in the parameters from the update method, so we can later pass in actual arguments in the main tab. We'll simply update or call this. Let's also add color so we can distinguish the displayed points from the path. I've already created a color method over here, and I've initialized it with a value of white. And because I want to set the color here, instead of just grabbing this, the public property, I'd rather just create a method called setColor and use that to set the color inside of my path class. So that will be setCol, and it'll take in a color. And when I set the color, it's going to be all the same. But feel free to do random colors for the points. That will also look nice. In the path class, now we can create our color, and then the other one I'm going to call guide color for the points because these are not important. Or actually with the animation, it's going to add to the design. So for this part, it is important, but because this class or these two classes, the point and the path, are being used in several other sketches, or I've used them for other letters in the 36 days of type, I didn't need to use the point every time. So calling them guide color or calling its color guide color is a better choice since it's not going to be shown in every other sketch. And this is how I'm going to set them. Because I want color to be different from guide color so they don't disappear or the points won't disappear in the path, I will first initialize color with a random value from the colors array. And as per usual, in every other video I've done, we're going to do a random index from 0 to colors.length. And because this is supposed to be an integer, we're going to have to cast it into an integer, making colors.length excluded from whatever values because it's going to floor every number. And now I'm going to do the same thing with guide color. However, now if guide color is equal to whatever the color is, I'm going to have to change it. And I can do that with a while loop. So I'm going to say while guide color is equal to color. So if they're always equal, then I want to change guide color until this becomes false. So this is going to get another index. Now we've ensured that our color is not equal to our guide color or points color. That was a lot of code with no visual results, so let's import our SVG and see how it looks. I've already saved my SVG file inside of my data folder, and if you want to know how I import the correct SVGs, then check the previous video, because on there I show you how you can save SVGs correctly from Illustrator that won't show up broken in processing, because that happens. And I also link to an SVG creator that you can use to export your shapes, and that works as well. So now that I have my file, I'm going to take its name. I'll just call it N. And then the majority of how I import SVGs as well is in the previous video. So I'll speed up this section so it's not a very long tutorial. And you can check the other one for this section because I explain a little bit more about the Geomerative library and how to import SVGs and the parameters that you're going to need to change for these sketches. Okay, I'll summarize what I just did. I started by importing the Geomerative library, defined an R shape called group, and an R point 2D array. Next, I initialized the Geomerative library, called the ignore style method to ignore the initial SVG styles and style the shape from processing. Then for the point spacing, I set the polygonizer length to 30. The bigger the number, the more spaces you get between the points. And then it's time to load the shape. So I assigned that to a group, centered the shape, and finally got the points from the SVG using the getPointsInPaths method and store them in the rPoints2D array. Time to create our paths. For our letter, we only have one path, but I'm still going to set up the sketch as if we have multiple paths, just in case I use other shapes some other time. So let's create our nested loops to iterate through the points2D dimensional array. This points array, simply put, is a collection of paths of points, which is what we defined as our classes. So in the outer loop, we'll define a point array, taking the length of the points of each path inside the rPoint array. It's as if we're transitioning everything to our own classes. I'll do that after getPointsInPaths because I'm going to need the points from this array. In the second loop, let's create a new instance of points, passing in the position from the rPoints array and appending it to the array created in the outer loop. And finally, we'll pass in the local points array into a new path and add that to the paths array list, which I'll create right here. In the draw method, we can now display the path after translating the canvas to the center. I've already added the translate method, so I can show you the shape. And just a quick explanation why I have to translate in order to show this correctly is because Geomerative draws the shape's top left corner at the 0, 0 point. So we've centered in the shape, which makes it draw from the center at that 0, 0 point. And by pushing the canvas, we can move the shape to the correct position then at the center of the canvas. Now to draw the path, we simply use a for in loop and call the display method, and this should show us how the shape looks. And voila, we have it. But I forgot to assign the color over here. So we still have white. I'm going to instead just say col for color. And then I'm going to call set color over here with guide color. Okay, that fixed it. And with every run, we're going to have a different color for the guides or for the points from the path itself. Now, because I'm using vertices instead of curved vertices, it's showing a little bit of kinks here and there. But if you add stroke join round to it, then it'll look a little bit nicer. Finally, time to make some selections. We can call the update method with random values for a rectangle and things will work out, but where's the fun in that? We want to see the selection, so I defined a method called showSelection that takes the 4 variables we need for a rectangular selection and drew it using vertices. The first point will be XY. The second point will be the width and Y because we're moving to the right. And then down to width and height. And finally, we're going to go back to the left. So we're back to X, but we're still at the height. And we can just close the shape instead of going up with another vertex. Before we call showSelection, let's define 4 variables for selection start position and end position. I'll call them select X, select Y, select width, and select height. And we'll use them as arguments for showSelection, which we'll call before the translate method. That way we don't have to shift it back by half a width and height. This is just a visual, so it doesn't matter as much as long as we're seeing it in the correct position. When we pass the values to the paths update method later, we'll have to shift the selection variables so they're at the correct position. But we'll get to that later. For now, let's focus on the visual. Because we haven't initialized any values for the 4 variables, we won't see anything, so let's initialize at least the selection's width and height and assign them to the values of mouse X and mouse Y. If I run the sketch, we'll see the selection, but its start point is fixed to 0, 0. And also let's fix this color. So up here, I'll just make it no fill. Simply changing the defaults for the whole sketch, and then a stroke of white. Now we have a better view of where it's selecting. If showing the selection underneath the shape is a problem for you, then you're going to have to show the selection after the display, but then you will have to shift it by width or by half the width and half the height on the opposite direction. Now, as you can see, the starting position is fixed. So let's adjust that, or let's give them values. First, we'll wrap the select width and select height with an if conditional to only get the mouse value when the variable start drawing is active. We'll define start drawing up here after the selection. I like to combine my variables based on their function together. So start drawing is related to the selection, and that's why I'm putting it up here. And if you think about it, how would you comment this out? If you have to add a comment after each little thing, then you're not combining them correctly, and it's going to look disorganized. And when you come back to your variables, if you want to change anything, you don't know what part is for what, because the more complex your code is, the harder it's going to be for you to get back up here and figure out which of these variables you're not going to need, or which of these variables relate to which part. And I'm going to initialize it with false. Usually selections happen when you click a mouse. So inside the mouse pressed method, we'll make the select x and select y equal mouse x and mouse y. Now every time I click the mouse, I'll get a new x and y value for the selection, and width and height will stay at 0, 0, since start drawing is false. Therefore, with every mouse click, I will also toggle the value of start drawing by setting it to not start drawing. So if it's false, then this is going to be true, and if this is true, this is going to be not true, meaning false. Now with every click, I get a new x and y value, but I still can't control the width and height of my selection, because now the live select width and select height are triggered since start drawing is true. However, select width and height are not sticking, and the x and y position keep changing. So inside the mouse pressed method, I'll add an if conditional that checks the status of start drawing and sets the position and size of the selection accordingly. So if start drawing is true, then set x and y, show me the live width and height. Otherwise, when I click again and start drawing becomes false, I stop moving the size and fix it to the last recorded mouse position. I also created a mouse method to give the cursor a different shape, and here's the code for that. I then called it in the draw method before show selection. And grabbed its color from the path, and then I gave it a size of 10. So it's going to have a cross shape. Now you can see the cross. And if I click and I click again, the selection sticks. Pretty cool. Now it's time to see some animation. Inside the for in loop in the draw method, we'll add the path update method, and we'll pass in the selection argument, but we'll subtract half of the width from the x and width and half of the height from the y and the height to shift it to the correct position. Because if I select right now with these values, it's not going to look right. Now let's check out what we have at the moment. We only have an animation inside of our selection. And now if I change the selection, that will stop and this will move. Let's also vary the points. So let's go to the point class, and I'm also adding the noise angle to the stroke weight. I'll use the cosine of the angle and the x step. And it is also why I added this absolute method, because this gives me negative values as well, and stroke weight doesn't take negative values. And if I run this again, the animation should look nicer. And last but not least, I want to show you the other scenarios for the selected method. So right now, all I can do is select from the top left corner to the bottom right, but I cannot do the same thing the other way around. So I'm going to have to add these scenarios to the selection or to the selected method. It's not that hard to do. All we're going to do is check whether the starting point is greater or less than the end point of our selection, or the width and height of our selection. So for the first one, it's going from the top left to the bottom right. So that means if x, the value of the x in the selection, is less than the width, or the y is less than the height, then this will be triggered. And we're going to have to do the other different scenarios. So I'm going to copy paste it just because I already have the code, but I wouldn't recommend copying and pasting, because doing it this way creates a lot of error, because you don't know what part you have changed and what part you haven't, since it's all already written out. But I've already tested the code and I already have the code in front of me to copy and paste from it, or to know exactly where I am at. So for this part, I'm also going to add comments so it's much easier for you to know where we're at. So this is going to be right up. That means that's where we're starting the selection from. So from the right and upward, going the opposite way, so down and to the left. And this is going to be left up. And for this, we'll do left down, and last one is right down. Now for right up, we know that the x is going to be greater than the width, because you're going from the bigger part, or the bigger numbers over here if you have a ruler, to the smaller number. So that's the opposite. But y is going to stay the same. And then here the selection is going to change. So if x is less this time than x, because x is going to be here, while the selection start position is going to be to the right of that. And y is going to stay the same because this stayed the same, and the same goes for the other x, where it's going to be greater than the width. And now for this, because it's left similar to this, x is going to stay the same, but y is going to change, because now we're going from the left side, but from down. And again, x is going to stay the same, but then we're going to flip the y's. And lastly, this one is going to change, but also the y over here is going to change, because now we're going the exact opposite of our base scenario. That means everything here is changing. And now if I run this, we should get a movement with any selection. So going from here, and then going from this side, and finally going from this side. Okay, we have a functioning sketch. If you've seen my letters from this sketch on Instagram, you'll see that I have one extra detail that you can add to your sketch, and that is some text or some mouse X and mouse Y values, or the selection values. To do that, I'll just call it guides. And this is how it goes. It'll be positioned at select X and select Y. And then the second one is going to be the same, but for width and height. And I'll do it right over here. And now it's much nicer to see where it's actually positioned. You can also make the sketch more interactive. You can add a key press method with keys for resetting the canvas, toggling the guides if you want to save your sketch without the selection and mouse, and anything else. Maybe you want to undo the selections, because that's what I did in my original sketch. I had an array of selection because I wanted to show where the previous selection was, but then when I wanted to save it, or if I wanted to remove the last selection, I can just do undo with a key press. Now it's time for you to experiment with this sketch and for me to sign off. So talk to you soon.